You know, our sun, it can be a pretty violent and unpredictable star. And now, for the very first time, a new eye in the sky has peered directly into the heart of one of its most powerful explosions. And in doing so, it just might have solved a huge mystery. So let's get right into it.
We've all seen those absolutely spectacular images, right? These giant eruptions just bursting from the sun's surface. But what's actually happening inside that explosion? I mean, what's the engine driving these massive events? Or for scientists, that's always been the real puzzle.
So at its core, a solar flare is basically a gigantic, sudden release of magnetic energy. Just try to imagine the sun's magnetic fields getting all tangled and twisted up and then snapping, like a super powerful cosmic rubber band. That snap unleashes this incredible burst of radiation and high-energy particles.
And here's the crucial thing to remember. These aren't just some distant fireworks we're watching. The energy from these flares travels all the way across the solar system, and yeah, it can directly impact our planet. This is what we call space weather.
So if you really want to understand this whole process, you need a completely new way of looking at it. And that brings us to Aditya-L1, India's very first dedicated solar observatory. It was designed to solve this exact puzzle.
Okay, and what's really incredible to me is the timeline. I mean, check this out. The mission launches in September 2023, it gets into its perfect orbit in January 2024, and then, just 1 month later, bam! It's in the right place at the right time to witness a monster solar eruption. I mean, talk about perfect timing.
Its location is absolutely key to its success. Aditya-L1 is parked at a special spot in space called Lagrange Point 1, or just L1. From this amazing vantage point, about 1.5 million kilometers from us, it can just stare at the sun 24/7. Our planet and the moon never get in the way. It's basically the perfect solar sentry post.
So what really makes this mission a total game changer? Well, it's packed with unique tools, including this really cool onboard AI that automatically spots flares. But the real breakthrough, the secret sauce, is its ability to see the sun in the near ultraviolet range. This was a massive blind spot for solar science, and Aditya-L1 is filling it.
And all that amazing technology got put to the test on February 22, 2024. An active region on the sun just unleashed a truly massive eruption. And you guessed it, Aditya-L1, with its unique vision, was watching.
Now this flare was classified as an X6.3, and on the scale of solar eruptions, X class is the absolute highest category you can get. So think of it like a Category 5 hurricane, but for the entire solar system. This was a seriously powerful event.
And here it is. This is the breakthrough moment. Using its Solar Ultraviolet Imaging Telescope, or SUIT, Aditya-L1 saw something incredible. 2 bright spots, or kernels, right at the very core of the flare. And these kernels were deep in the sun's lower atmosphere, a region we've just never been able to see with this kind of clarity during a powerful flare before.
Now, the reason this view is so special is because it was taken in near ultraviolet light. Our atmosphere here on Earth completely blocks this radiation, so the only way to see it is from space. You can kind of think of SUIT's filters as a pair of super specialized sunglasses that block out the sun's overwhelming glare and let us peek into specific layers of its atmosphere that have always been hidden from us.
So, okay, what's the big deal about seeing these 2 bright spots? Well, this is where a huge, long-standing solar mystery finally starts to come together.
All right, so for years, scientists have known that a flare explosion violently heats up the sun's outer atmosphere, the corona, to millions of degrees. The problem was they couldn't see the link. Where was the smoking gun? How did the energy from that initial blast way down in the lower atmosphere get all the way up to superheat the corona?
And this observation is that missing link. It's the whole chain of events. So the flare erupts deep down in the sun's lower atmosphere. And for the very first time, by seeing those kernels with SUIT, while simultaneously measuring the temperature spike in the corona with other instruments, scientists could directly connect the dots. The flare erupts below, and almost instantly, the corona heats up above. Problem solved.
As one of the lead scientists, Dr. Sami Solanki, put it, this isn't just one small piece of new info. Thanks to Aditya-L1, we now have a complete picture of how energy flows through the sun's atmosphere during a flare. It's like we were watching a movie that had a crucial scene cut out, and Aditya-L1 just filled in that gap for us.
So, a solar physics breakthrough is obviously fascinating stuff, but why does it matter to us here on our tiny blue planet millions of kilometers away? What's the bigger picture?
Remember that space weather we talked about? That blast of energy from a solar flare can have very real, very serious consequences. It can knock out radio communications, it can damage the satellites we rely on for GPS and weather forecasting, and in extreme cases, it could even overload power grids right here on the ground. Of course, on the bright side, it's also what creates those beautiful auroras. By finally understanding the fundamental physics of how these explosions start and release their energy, scientists can build much, much better models. And better models mean better predictions. This is a huge leap forward toward being able to accurately forecast space weather, kind of like how we forecast a hurricane here on Earth.
Aditya-L1 has just opened an entirely new window onto our star. It's given us an unprecedented look into the engine room of its most powerful storms. And that leaves us with a really fascinating thought. For the first time, we might finally be getting closer to predicting the sun's next move.